Polynomial stands for an equation of the form p of x, expression of the form p of x is equal to a to the base n, x to the power of n, then plus a to the power of n minus 1, x to the power of n minus 1, plus, as you can continue this particular concept, plus a to the base 1 x plus a to the power 0. So this is the expression, okay, and in this we know that this value will not be equal to 0. Second thing, this a n minus 1, a1, a0, all these values are all constants. It means you will have values here, minus 2, plus 2, plus 3 like that. This is called a polynomial, right? The next concept of polynomial is degree. What do you mean by degree? Suppose we are given a polynomial p of x is equal to, now we can take up any particular polynomial. Suppose if I take an example, ax square plus bx plus c. So degree stands for the highest power of x. You can see x here and x here. So this too is the degree of the polynomial. Now polynomials are of three types. Number 1, linear polynomial. Number 2, quadratic polynomial. Number 3, cubic polynomial. Now let's see the differences. Between these three. A polynomial of degree 1, I write here, degree 1. A polynomial of degree 2, a polynomial of degree 3. Now, a polynomial degree 1 is called a linear polynomial. For example, if I have this, example 2x plus 5. You can see the degree of the variable x is 1 here. That is why it is termed as a linear polynomial. Another example that I can take is root 5x plus 27. Here the degree of variable x is 1. Hence it is a linear polynomial. Now a polynomial having degree 2 is termed as a quadratic polynomial. For example, 2x square plus 5x plus 2. As you can see, in the variable the highest degree is 2. Hence, it is termed as a quadratic polynomial. Now, a cubic polynomial, a polynomial having highest power or highest degree of variable x is termed as a cubic polynomial. For example, x cubed minus 3x square plus 5x minus 2. So, this is an example of a polynomial which is cubic. Now, when we talk about value of a polynomial, the next concept, the basic concept of it. Value of a polynomial, that is, if I am given any kind of polynomial, for example, I have the general equation ax square plus bx plus c, and I keep any particular value k. It might be minus 1, it might be 2, it might be 3, it might be minus 3, 4. Okay? If I place this value in this equation, then the value obtained by replacing x by k is called the value of px. For example, this k is to be placed here. A into k square plus b into k plus c is equal to 0. It means this value satisfies the polynomial equation. The next concept that we should know is zero of a polynomial. Now, suppose we are given a polynomial equation a is equal to ax square plus bx plus c. If we are given this, now what do we mean by zero? Zero stands for a real number. It might be negative, it might be positive. Okay? If by placing that value, suppose if I have minus 2, if I place this value in this type of equation, I should get the answer as 0. Understood? So if you place the value, any real number which when placed in an equation, you get the resultant as 0. That is termed as zero of a polynomial. Next, how many zeros does an equation have? Number of zeros. A linear polynomial, suppose if I have a linear polynomial, p of x is equal to ax plus b, that is the variable, the degree is 1 here, variable x over x. Alright, it has only one zero. 1 0 means only one value of x for which the whole equation becomes 0, and that is given by minus b upon a. Okay, now next is geometric meaning. We don't need to go for that, but I would say that we would know different types of graphs when you are obtaining a line, right? So you write here geometric meaning of zero. Now generally when you place the values, okay, then you will see that you will obtain a graph like this. X axis, y axis, you see a straight line here. Second, you might obtain a graph like this. It opens upwards. That is called parabola. You might also obtain graph like this. Alright, now there are three situations out here. Whenever we obtain a straight line, okay, suppose we are given a line and the line is given by the equation y is equal to ax plus b. If we are given this line, then we obtain a straight line. When do we obtain a straight line? It intersects the x-axis only at one point. It means it will have the coordinate minus b upon a, and there is no value of y on the x-axis. That time we obtain a straight line. Now when you see that the curve, the graph of an quadratic equation here. Now when you talk about this kind of a graph, then ax square plus by plus c, this kind of a graph is obtained here. Then we see that if the value of a, if this value is greater than 0, then the graph will open upwards. If the value here a is less than 0, then the graph will open downwards. Exercise 2.1, question number 1. You can see that we are given 6 graphs out here. We have to find out in this, for some of the polynomial px, find the number of zeros of px. Now we already know number of zeros stands for the number of places where the graph intersects the x-axis. You can see this graph is not intersecting the x-axis, hence the number of zeros is 0. This graph is not touching the x-axis. Okay, look at this one. This graph is touching the x-axis at one point, hence the number of zeros is 1. Okay, if you see a third one, then that graph is touching the x-axis, and just mark it dark here, see 1. This graph is touching the x-axis at 3 points, hence the number of zeros is 3. This graph is touching the x-axis at 2 points, hence number of zeros is 2. This graph is touching the x-axis at 4 points, hence the zeros of this graph are 4. This graph is touching the x-axis at 3 points, hence the number of zeros is 3. Exercise 2.2, question number 1. We have to find the zeros of the following quadratic polynomials and verify the relation between the zeros and the coefficients. In this sum we are given, the first one as x square minus 2x minus 8. Now finding zeros means we have to find the values of x here. If you see here, look at the last value. We have to look for two numbers which were multiplied gives minus 8 and the same numbers on addition and subtraction gives minus 2. Those two numbers are 4 2s are 8. Okay, and if I subtract these two, then I get minus 2. You can see middle term is obtained here, and on multiplying them, plus and minus, minus 4 2s are 8. Now write these values here. Split the middle term, minus 4x plus 2x minus 8. Now make pairs out of these two. Out of this first one, remove x common, you get x minus 4. Plus 2 common, x minus 4. Always remember, this factor will always be repeated. Now write the repeated factor first, x minus 4, and remaining outside the brackets are x plus 2. Now when I mark it equal to 0, for example, x minus 4 is 0, x is equal to 4, and second value will be x plus 2 is 0, x is equal to minus 2. So these are my two zeros of the equation. Okay, now what am I supposed to do here? I have to find the relation between the zeros and the coefficients. If I compare this value with ax square plus bx plus c, then first I have the formula of sum of zeros. Now sum of zeros means 4 minus 2, 4 plus minus 2, I get answer as 2. Sum of 0 is given by the formula minus b upon a. According to this equation, sum of zeros will be minus b upon a. So what is the value of minus b? Minus 2. And value of a is 1. You cannot see a here, it means 1. So this answer will be 2. You can see both the answers are same. I took the zeros, added them together, I got this answer. And according to coefficient, these are the coefficients. See, a is a coefficient, b is a coefficient, c is a coefficient. So when I take the relation of coefficients for sum of zeros, this is the value. I have only replaced them from here. You can see the answers are same. When I go for product of zeros, now product of zeros means take the first value of x, second value of x, I get answer as minus 8. Product of zeros according to coefficient is given by the relation c by a. What is the value of c? Minus 8. A 1. You can see both the values are same. So here I have verified the relation between the zeros and the coefficients. Next question. 4s square minus 4s plus 1. Whenever you are given the value of a in a polynomial, multiply the first value by the last one. So you get 4 ones are 4 here. Now we search for two numbers, each one multiplied gives 4, and the same number on addition subtraction gives this middle term. So those two numbers will be minus 2 minus 2. How do I know? Minus into minus plus, 2 2s are 4. And minus minus plus, but sign of minus and addition comes up, and this becomes minus 4. So you can see the two numbers are minus 2 and minus 2. Implies that 4s square minus 2s plus 1. Now making pairs, out of these two, 2 is common, s is common. So you are left with 2s minus 1. Now here, nothing is common, so you take 1. Okay, when you take 1 as common, then inside the bracket you will repeat this factor. You can see this, these two are same. So one of the factor is 2s minus 1 and numbers outside 2s minus 1. Comparing it with 0, 2s minus 1 is equal to 0, therefore s is equal to 1 upon 2. Similarly, you get the same answer here. Now, going for sum of zeros. Sum of zeros means see the value here. First value 1 upon 2. These factors are same. So second value will be same. LCM 2, 1 plus 1, 2, cancel, you get the answer 1. Now, as far as sum of 0 is concerned with the coefficients, the value is minus b upon a. Minus. What is the value of b here? Minus 4. Value of a here, 4. So you cancel both and you get the answer as plus 1. See, the answers are the same. When you go for product of zeros means the first value of 0 is 1 by 2, second 1 by 2, so you get 1 by 4 as the answer. Comparing it with the coefficients from here, the coefficient will be C by A. What is the value of C? 1. What is the value of A? 4. So you can see the answers are same. In the next question, we are given 6x square minus 3x minus 7x. So if we see the general form of equation is ax square plus bx plus c. First we will rearrange this. After rearrangement, it becomes 6x square minus 7x minus 3. Now, look at the first value. We have a. Multiply this with the last one. 6 3s are 18. So when you see the value that is minus 18, you can see a minus sign here. Now, we have to search for two numbers which when multiplied gives minus 18 and the same numbers on addition subtraction gives minus 7. Those two numbers are 9 and 2. See how to solve it. Minus and plus. Why did I take minus 9? Because when I add them, 9 minus 2, 7, this sign has negative sign here. It is only possible if I have a negative sign with 9. When I multiply both, minus into plus, minus, 9 2s are 18. Now I can split my middle term using these two values. Here I get 6x square minus 9x plus 2x minus 3 is equal to 0. Making pairs, and then out of these two, 3 can be taken common as 3 can divide both these numbers and x can be taken common. So you get 2x minus 3 plus, you see nothing common here, you take 1 common. So one of the factors that's repeated is 2x minus 3 and the other factor outside the bracket is 3x plus 1. Let's take it, compare it with 0. 2x minus 3 is equal to 0. And second, 3x plus 1 is equal to 0. Therefore, we have x is equal to 3 upon 2 as one value and x is equal to minus 1 upon 3 as the other value. Now, we take the sum of zeros. Sum of zeros taking both the values here. 3 upon 2 plus minus 1 upon 2. You get 3 minus 1 upon 2. When you cancel, you get the answer as 1. Okay. Now comparing with coefficients here, minus b upon a. So you take this one. Okay, because this is the right form. Ax square plus bx plus c. Minus 7 upon 6. Ready? Taking value of sum of zeros, we have 3 upon 2 plus minus 1 upon 3. Taking LCM, we get the value as 6. Divide LCM by this. 2 3s are 6. Multiply 3 with the top number. This is a 9 minus. Divide 6 by 3. 3 2s are 6. Multiply by 2 by 1. We get 2. So answer is 7 by 6. Comparing with coefficients, we get minus. The value of b is minus 7 upon value of a is 6. So you get 7 by 6 here. Product of zeros. Taking these two values, you have 3 upon 2 multiplied by minus 1 upon 3. You get the answer as minus 3 upon 6 and cancel these two values, you get minus 1 by 2. Comparing with the coefficients, product of zeros is given by c by a. The value of c is minus 3. The value of a is 6. Cancelling them, you get minus 1 by 2. You see, the values are same. In the next question, we have 4u square plus 8u as equation. Taking 4 common, u common from here, you get u plus 2. Now we have two values here. U plus 2 is equal to 0. Therefore, u is equal to minus 2. And second one, 4u is equal to 0. Therefore, u is equal to 0. So these are the zeros of the equation. Sum of zeros, let's add them. Minus 2 plus 0 is equal to minus 2. Taking that value, minus b upon a. Now, if you see here, the value of b is minus a upon value of A is 4. Cancel, you get the answer -2. So comparing, you see the answers are same. Now for product of zeros, take these two values, -2 into 0. So any number multiplied by 0 is always a 0. Comparing by coefficients, C by A. If you see here, that there is no value of C here. No constant term here. It is ax square plus bx plus C is not available here. So we have a 0 in place of C. Hence, the comparison of product of zeros with coefficients and zeros is 0 here. Moving to the next question, 3 square minus 15. Now if we see that we cannot factorize it properly, we have the first term and the last term, ax square plus c. Alright? So we'll try to make it a polynomial equation first. If I take this value, t whole square minus under root 15 whole square, I get 15 again. This value is compared to the formula a square minus b square, which is going to give me a minus b and a plus b. Now taking those values and comparing with 0, t minus root 15 is equal to 0, therefore t is equal to plus root 15. Second value, t plus root 15 is equal to 0, therefore t is equal to minus under root 15. Taking these two values as 0, sum of zeros is given by under root 15 plus minus under root 15, the answer is 0. The value can be compared with b by a, minus b by a. Now here, if you see, then the value of b is missing from here. How do I know? If I compare with general formula for polynomial, ax square plus b isn't present here. It means the value of b is 0 and the value of a is 1. With t there is no number, so it means 1. This answer is 0. Product of zeros, take both the digits, under root 15 multiplied by minus under root 15. When you compare both the values, then you get the answer as under root into under root, that is removed, 15 into 15, only 15, minus sign comes up here. From coefficients, you get the value as c by a. The value of c is given here, minus 15 upon 1. You can see that the value of product of zeros with the coefficients is the same. Moving to next question, if we see, in the next question we are given ax square, 3x square minus x minus 4. You can see the value of a is given here. Multiply this with the last value. So the answer you get is minus 12. Now we have to search for two numbers which will multiply gives minus 12 and the same numbers or addition or subtraction so should give this minus 1 at the center. So those two numbers are 4 and 3. As it is minus 1 here, I will take bigger number as minus 5. You can see here. If I multiply these two, 4 3 are 12, I get minus 12. So replacing the middle term with these two, I get 3x square plus 3x minus 4x minus 4. Making pairs, removing 3 common from the first and x common, you get x plus 1. Taking minus common outside, from here taking 4 common, you get x minus into, this should give plus. Now why did I make it plus? Because first of all I told you that this factor should be repeated, and suppose here I give a minus here, then that will give me minus into minus plus, but we have a minus sign here. So we take a plus sign in between there. Comparing with 0, x plus 1 is equal to 0, therefore x is equal to minus 1. Second, 3x minus 4 is 0, 3x is equal to 4, therefore x is equal to 4 by 3. Now we have got the two zeros, sum of zeros, let's write them. Minus 1 plus 4 upon 3, taking LCM, you get minus 3 plus 4 upon 3 is equal to 1 upon 3. Comparing with the coefficients, minus b by a. The value of minus b is minus 1. The value of a is 3. You get 1 by 3. You can see the values are the same. Product of zeros, multiply both the zeros here. minus 1 into 4 by 3 is equal to minus 4 by 3. Compare coefficient C by A. The value of C is minus 4. The value of A is 3. So you can see the answers are the same. Moving to question number 2 of exercise 2.2. We will form quadratic equations using these values of zeros which are given to us. As you see, the first value indicates the sum of zeros. The second value indicates the product of value. Now I am going to use the formula method to solve this. According to formula method, we have x square minus sum of zeros into x plus product of zeros. Now see how to solve it. Keep x square as it is minus. In place of sum of 0, the value is 1 by 4 into x plus product of zeros minus 1. X square, you see this, it becomes x upon 4 minus 1. Taking LCM here, you get 4x square minus x minus 4. Actually you get upon 4 here. We have to remove this from here. So keep it as a 0 in front of it, and when you multiply 2, this is the quadratic equation using these two values. The sum is over. Let's try the second one. Using the same formula, we have x square minus root 2 sum of 0 into x plus 1 upon 2. Taking LCM as 2, you get the answer as 2x square minus 2 root 2x plus 1. This is the quadratic equation. Going to third term, the formula is x square minus sum of zeros 0 into x plus product of zeros under root 3. So the answer is x square minus root 3. You can write as x minus root 3 and x plus root 3. This is the equation. Taking the next sum, we have x square minus sum of 0 is 1 into x plus product of 0 is 1. Look at the equation as x square minus x plus 1. Taking the next sum, using formula x square minus sum of zeros minus 1 upon 4 into x plus product of zeros. We get, taking LCM here, LCM is 4, so you get 4x square minus and minus plus x plus 1. Take the next sum, you get x square minus sum of 0 4 into x plus product of 0. You get x square minus 4x plus 1.